The render node converts the input scene into a rendered texture. This allows visualizing 3D meshes as 2D images. For optimization purposes, the node has multiple render modes to represent the rendered scene, either as fully rendered meshes, bounding boxes, or a simplification of the original mesh. It also uses a spatial grid acceleration structure to keep render times as low as possible. Depending on the complexity of the input scene, you may have to adjust the number of tiles, keeping them as high as necessary and as low as possible. The rendered normals of the mesh can either be face normals or smooth vertex normals, which are calculated when activating smooth normals. The render settings parameters are meant to adjust the size and position of the scene in the render window. Auto size scales the scene so it fits into the window. Auto position centers the scene by calculating the median point of all meshes. Deactivating this parameter uses the origin of the scene. The scale and position parameters adjust the size and offset of the scene. The node provides different outputs to give you as much data as possible. Some of the generated outputs are necessary for other nodes. The position output renders the X, Y, and Z position of the scene as RGB values. The UV output maps the UV values of the meshes. This output is necessary for texture or material mapping with dedicated nodes for that purpose. The normal output renders the normals of the mesh. The mesh indices output generates a grayscale texture, with the indices of each mesh in the scene as an integer value. The distances output renders the distance from vertex to edge for every triangle. The mesh data outputs create two textures, the first containing triangle data such as edge lengths and area. The second output contains the barycentric representation of each triangle in the scene.